1. Gravitation. We have seen in the previous standard that the gravitational force is a universal force and it acts not only between two objects on the Earth but also between any two objects in the universe. Let us now learn how this force was discovered. Gravitation. As we have learnt, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? After much thought, he came to the conclusion that the Earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the Earth. The direction from the apple on the tree to the center of the Earth is the vertical direction at the position of the apple, and thus, the apple falls vertically downwards. Figure 1.1 on the left shows an apple tree on the Earth. The force on an apple on the tree is towards the center of the Earth, i.e., along the perpendicular from the position of the apple to the surface of the Earth. The figure also shows the gravitational force between the Earth and the Moon. The distances in the figure are not according to scale. Earth. Falling apple. Moon gravitational force. Earth. Newton thought that if the force of gravitation acts on apples on the tree at different heights from the surface of the Earth, can it also act on objects at even greater heights, much farther away from the Earth? Like, for example, the Moon. Can it act on even farther objects like the other planets? Force and motionway have seen that a force is necessary to change the speed as well as the direction of motion of an object. Introduction to Great scientists. Sir Isaac Newton was one of the greatest scientists of recent times. He was born in England. He gave his laws of motion, equations of motion and theory of gravity in his book Principia. Before this book was written, Kepler had given 3 laws describing planetary motions. However, the reason why planets move in the way described by Kepler's laws was not known. Newton, with his theory of gravity, mathematically derived Kepler's laws. Try this: tie a stone to one end. In addition to this, Newton did groundbreaking work in several areas including light, heat, sound and mathematics. He invented a new branch of mathematics. This is called calculus and has wide-ranging applications in physics and mathematics. He was the first scientist to construct a reflecting telescope. Circular motion and centripetal force. Try this: tie a stone to one end of a string. Take the other end in your hand and rotate the string so that the stone moves along a circle as shown in figure 1.2a. Are you applying any force on the stone? In which direction is this force acting? How will you stop this force from acting? What will be the effect on the stone? As long as we are holding the string, we are pulling the stone towards us, i.e., towards the center of the circle, and are applying a force towards it. The force stops acting if we release the string. In this case, the stone will fly off along a straight line which is the tangent to the circle at the position of the stone when the string is released. Because that is the direction of its velocity at that instant of time. You may recall that we have performed a similar activity previously in which a 5 rupee coin kept on a rotating circular disc flies off the disc along the tangent to the disc. Thus, A force acts on any object moving along a circle and it is directed towards the center of the circle. This is called the centripetal force. Centripetal means center-seeking, i.e., the object tries to go towards the center of the circle because of this force. 1.2 A stone tied to a string, moving along a circular path and its velocity in tangential direction. You know that the Moon, which is the natural satellite of the Earth, goes round it in a definite orbit. The direction of motion of the Moon as well as its speed constantly changes during this motion. Do you think some force is constantly acting on the Moon? What must be the direction of this force? How would its motion have been if no such force acted on it? Do the other planets in the solar system revolve around the Sun in a similar fashion? Is similar force acting on them? What must be its direction? From the above activity, example and questions it is clear that for the Moon to go around the Earth, there must be a force which is exerted on the Moon and this force must be exerted by the Earth which attracts the Moon towards itself. Similarly, the Sun There must be a force which is exerted on the Moon and this force must be exerted by the Earth. There must be a force which is exerted on the Moon and this force must be exerted by the Earth which attracts the Moon towards itself. Similarly, there must be a Kepler's law's planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of the planets' positions were made with naked eyes. By the 16th century a lot of data were available about planetary positions and motion. Johannes Kepler studied these data. He noticed that the motion of planets follows certain laws. He stated 3 laws describing planetary motion. These are known as Kepler's laws which are given below. Kepler's first law. A. Cf1 F2. The orbit of a planet is an ellipse with the Sun at one of the foci. Figure 1.4 shows the elliptical orbit of a planet revolving around the Sun. The position of the Sun is indicated by S. Kepler's second law. The line joining the planet and the Sun sweeps equal areas in equal intervals of time. A, B and C, D are distances covered by the planet in equal time, i.e., after equal intervals of time. The positions of the planets starting from A and C are shown by B and D respectively. Kepler's third law. The square of its period of revolution around the Sun is directly proportional to the cube of the mean distance of a planet from the Sun. Thus, if r is the average distance of the planet from the Sun and t is its period of revolution, then t. Kepler obtained these laws simply from the study of the positions of planets obtained by regular observations. He had no explanation as to why planets obey these laws. We will see below how these laws helped Newton in the formulation of his theory of gravitation.